Somewhere out in the dark, 8 worlds are turning, and not one of them was made to hold you. Tonight, we are going to explore what would really happen to a human body on every planet in our solar system. The things that NASA and a handful of small, doomed spacecraft have quietly discovered out there in the cold. On one of these worlds, the air alone would crush you like an empty bottle in about 5 seconds. On another, you would be folded, slowly and almost gently, into something close to a diamond. And what these machines found, world by world, turned out to be stranger and more beautiful than anyone watching from home had dared to imagine. How can a planet rain acid from a yellow sky? Where does a wind go when it never stops? When it screams at more than 1,000 miles an hour and never once pauses for breath? And why is it that out of all these enormous, ancient, magnificent worlds, the only one that does not want to end you is the small blue one you are resting on right now? Until, by the time the night is over, you finally understand just how rare that quiet safety truly is. If you find a quiet comfort in drifting off to the strange wonders of distant worlds, you might gently tap the like button or follow along so that these slow journeys through the dark can keep finding their way back to you. Let your shoulders drop and let us begin. Let us start with something easy to forget. You are a creature of one single place. Out of the entire universe, every ocean of stars, every cloud of glowing gas, every spinning world that has ever existed or ever will, there is exactly one address where a body like yours can simply stand outside and breathe. You are standing on it, or lying on it, more likely, as the night settles in around you. And that fact, so ordinary that we almost never think about it, is one of the strangest and most precious things in all of creation. We were built by this one world, for this one world. Your lungs were shaped by the thickness of this air. Your blood is held together by the gentle press of this atmosphere. Your skin can sit comfortably in this temperature, somewhere in the warm middle of all the possible temperatures the universe has to offer. You have lived your whole life inside a tiny, perfect ribbon of safety, a thin shell of breathable air wrapped around a ball of rock. And you have never once had to think about how thin that shell really is. Tonight, we are going to leave it, not in body. Of course, your body is going to stay exactly where it is, warm and held and safe. But in imagination, we are going to travel outward, away from the small blue world, and we are going to visit the other planets one by one. We are going to stand on their surfaces or sink into their skies. And we are going to ask a simple and slightly haunting question about each of them. If you actually went there, with nothing more than a spacesuit and a fragile human body, what would happen to you? How long would you last? And what, exactly, would the planet use to undo you? It sounds like a grim question, but it is really a question about wonder. Because every way that these worlds could end a human life is also a window into what those worlds actually are. The thing that would kill you on Venus is the very same thing that makes Venus glow like a furnace beneath its clouds. The thing that would freeze you on Pluto is the same deep silence that has kept that little world almost unchanged since the solar system was young. To learn how each planet would end you is to learn in the most personal way possible what each planet truly is. And there is no need to feel any fear in asking it, here in the safety of your own quiet room. This is not a frightening journey. It is a tender one. We are not going to dwell on the ending of anything for its own sake. We are going to use each imagined ending as a small lantern held up to a strange and distant world, so that for a moment we can see clearly what is really out there. The crushing weight that would fold you closed on Venus is the same weight that has kept that planet hidden from us for most of human history. The cold that would still your heart on Pluto is the same cold that has preserved that little world almost untouched since the dawn of the solar system, like a fly in amber, holding its secrets safe across billions of years. Every danger is also a doorway. Behind each one is a fact and a wonder, and a small piece of the great patient story of how the worlds came to be. So let go of any unease. You are perfectly safe. We are only going out to look. And here is the gentle truth that runs underneath all of it. We know these things not because anyone ever went and died out there, but because we sent machines in our place. Small, patient, beautifully made machines. We built them on workbenches and in clean, white rooms, gave them cameras and instruments instead of eyes and hands, and then we launched them across distances so vast that the numbers stop meaning anything. And one by one, we sent them down into places that would destroy them. We knew, when we built some of them, that they were going to their deaths. We sent them anyway, and as they died, they sent home everything they were learning, right up until the final second. So this is also a story about them, about the machines that went where we could not, and the people who built them, and stayed up through the long nights waiting for a signal to come back across the emptiness. Tonight, as we visit each world, we will remember the little explorer that actually went there and gave its life to learn what we are about to learn. Nothing out there has ever harmed a single human being. Every wound these planets could give, they have only ever given to our machines. And our machines told us everything, so that you could lie here in safety and simply listen. Let us talk first about how fragile we really are, because it is easy to overestimate ourselves. On Earth, a human being feels sturdy. We climb mountains. We dive deep into the sea. We survive blizzards and deserts and storms. We think of ourselves as tough. But almost all of that toughness depends on the planet quietly doing its part. Take away the breathable air, and a person has only a few minutes. Take away the gentle pressure, and the body begins to fail in seconds. Move the temperature even a little outside its narrow comfort, in either direction, and the soft machinery inside us starts to break. Think of how small the safe range really is. On Earth, the hottest air ever recorded and the coldest air ever recorded are separated by less than 300 degrees. That feels like a lot. But out in the solar system, that entire range, the full sweep between the hottest desert and the coldest polar night our planet has ever known, is just a rounding error. There are worlds out there hot enough to melt lead at the surface. and worlds so cold that the air itself would freeze into frost on the ground. We live in the one narrow doorway between those extremes, and we almost never notice the door. And the distances we are about to cross are just as humbling as the temperatures. We say the words easily, the names of the planets, as though they were towns along a familiar road. But the road is almost beyond imagining. Light itself, the fastest thing there is, takes only a moment to cross a room. Yet it takes minutes to travel from the sun to the earth, and hours to reach the farthest worlds we will visit tonight. The little spacecraft we sent out there did not move at the speed of light. They crawled, by comparison, and even crawling at many thousands of miles an hour. Some of them traveled for 9 years, or 10, or more, simply to arrive. A child could be born, and grow, and finish school, in the time it took one of these machines to reach its destination. That is the true shape of the solar system. It is not a tidy diagram in a book. It is an ocean of emptiness so wide that crossing even a small part of it is the patient work of years. There is something soothing in that patience. If you let there be, we tend to live our lives in a hurry, measuring things in minutes and hours, rushing from one small urgency to the next. But the solar system does not hurry. The planets have been turning on their long, slow orbits for more than 4 billion years, and they will keep turning for billions more. Whether or not anyone is watching, whether or not anyone remembers. The light leaving the sun right now will not reach the outer worlds until you are long asleep. Out there, time moves like deep water, slow and enormous and calm. Tonight, you are simply going to drift through it, in no hurry at all, with nowhere you need to arrive. So keep that softness in mind as we travel, not as something frightening, but as something tender. You are a soft, warm, breathing thing, built for one gentle world. And we are about to look out at all the worlds that are not gentle at all. There is a strange comfort in that. By the end of the night, the most ordinary fact about your life, that you can simply lie there and breathe, may feel like the small miracle it has secretly always been. Now let us begin to move. In your mind, lift away from the surface of the earth. Watch the blue and white of it shrink behind you, the clouds, the oceans, the thin bright line of the atmosphere glowing at the edge. Turn toward the sun, that steady fire at the center of everything, and let us travel inward, toward the worlds that orbit closest to the flame. The first one we reach is the smallest of all the true planets, a scarred gray world racing around the sun faster than any other. This is Mercury. Mercury is a world of almost unbelievable contradictions, and it is the first place that teaches us a deep and surprising lesson. The thing that makes a planet deadly is not always the thing you would guess. You might assume that the planet closest to the sun would simply be the hottest, a single unbearable furnace, and that would be the end of the story. But Mercury is far stranger than that. Mercury is both the most scorched and one of the most frozen places a person could ever stand. sometimes within the same small world, separated only by the line between day and night. Let us start on the night side, because it is the part most people never think about. Mercury is close to the Sun, only about 36 million miles away, which is less than half the distance from the Sun to the Earth. From Mercury, the Sun would look enormous, a great bright disk far larger than the one you are used to. And Mercury keeps its own strange and dreamlike sense of time. It races around the Sun faster than any other planet, finishing a whole year in only about 88 Earth days. And yet it turns on its own axis so slowly that a single day there, one full passage from sunrise to the next sunrise, stretches out to around 176 Earth days. Think of that. On Mercury, the day lasts longer than the year. The Sun would creep across that black sky with unbearable slowness, taking the better part of 3 Earth months simply to climb from the horizon to overhead and sink down again. There would be no quick relief of nightfall, no comforting rhythm of morning and evening. There would only be one impossibly long, scorching afternoon, followed by one impossibly long, freezing night, each of them lasting for weeks upon weeks. Time itself moves strangely on the little world nearest the Sun, and yet, on the night side of Mercury, you would freeze. The reason is something we take completely for granted at home. Mercury has almost no atmosphere. It has no blanket of air to hold on to the heat. So the moment the Sun goes down, all that warmth simply leaks away into space, and the surface temperature plunges to around 290 degrees below 0 Fahrenheit. Imagine stepping out onto that dark ground. At first, surprisingly, you would feel fine. The cold of space does not rush into you the way cold water does. Space is mostly empty, so there is very little around you to pull the heat out quickly. You could walk a little. You could look up at that black sky, crowded with stars, unblurred by any air, sharper and more numerous than any sky you have ever seen from Earth. For a few moments, it would simply be beautiful. And then, slowly, the cold would begin to find you. It would start in your fingers, a little numbness, a faint tingling, the kind of feeling you might ignore on a winter walk. Then a shiver, deep and involuntary, as your body began burning its own warmth to fight the cold. This is hypothermia, and it does not announce itself loudly. It creeps. Your core temperature would slip from its normal warmth down to around 95 degrees Fahrenheit, then lower, and as it fell, your thoughts would begin to slow and tangle. People in the late stages of hypothermia often feel strangely calm, even confused into a kind of dreaminess. Your muscles would stiffen, movement would become difficult, then nearly impossible, and still, for a while, you would be alive. It would take roughly an hour for the night side of Mercury to finish what it had started: slow, cold, and quiet. Beneath the largest field of stars a human eye has ever seen. Now turn toward the dawn, because Mercury has another face entirely. As that enormous sun climbs over the horizon, the day side of Mercury becomes a place of fire. The surface temperature there can reach around 800 degrees Fahrenheit, hot enough to melt some metals, only a little cooler than the worst that Venus has to offer. But on the day side, the heat is only part of the danger. The other part is invisible, and it pours down without mercy. With no real atmosphere and almost no magnetic shield, Mercury has nothing to stop the raw radiation of the sun from striking the ground directly. If you stood on the day side without protection, that radiation would begin damaging the delicate machinery inside your cells almost instantly, in less than 1,000th of a second. Your skin would burn. Not from a flame, but from the sheer flood of energy. Inside the warm dark of your body, the long, delicate strands that carry the instructions for life would begin to break and scramble. The heat would push your core temperature up past 102 degrees Fahrenheit and keep climbing. You would feel nauseous, then dizzy, then lost in a feverish confusion as your body tried and failed to cool itself. Within minutes, you would lose consciousness, somewhere between the heat and the radiation, on a bright gray plain with the giant sun hanging overhead. We know Mercury so well now because of two patient explorers. The first was a spacecraft that swept past Mercury 3 separate times in the 1970s, snapping the first close photographs humanity had ever seen of that cratered face. For decades, that was almost all we had. A handful of fly-by glimpses of a world we could barely reach. Getting to Mercury is strangely hard. Harder in some ways than going to the outer planets, because the sun's gravity keeps pulling a spacecraft faster and faster as it falls inward. And slowing down enough to actually stop there takes enormous patience and clever looping paths through space. It was not until many years later that a second probe finally settled into orbit around Mercury and circled it for 4 years, mapping every scar, before its mission ended and it was allowed to fall and strike the surface, becoming part of the very world it had come to study. There is something quietly moving in that. We sent a made thing across the burning inner solar system, taught it to dodge the sun's pull, let it circle a world that no human could survive for an hour, and at the end, gently let it come to rest there forever. It is still on Mercury now. A small, silent piece of human craftsmanship, lying in the dust of the fastest, most extreme little planet we know. And because of it, you can rest here tonight and picture that world clearly. The frozen night and the burning day, without ever having to feel either one. Let us move on. Drift outward from Mercury, away from that scorched and frozen rock. And the next world we reach is one that fooled us for a very long time. It is roughly the same size as Earth. It is wrapped in thick, soft, glowing clouds. For centuries, people looked at it and imagined a warm twin of our own world hiding beneath that haze. Perhaps with steaming jungles, perhaps with vast, warm oceans, perhaps even with life. They named it after the goddess of love and beauty. From a distance, it is the brightest and loveliest point of light in the evening sky. This is Venus, and almost everything those dreamers imagined was wrong. For a very long time, the dreaming was all we had. Venus keeps her surface wrapped in those thick, unbroken clouds. And no telescope on Earth, however fine, could ever peer through them to see the ground below. So people filled in the blank with hope. Some imagined warm swamps and dripping ferns, a younger, wilder version of our own world. Some imagined a planet-wide ocean rolling beneath the clouds. Writers set stories there of jungles and seas and strange, gentle life. It was the great romantic mystery of the inner solar system, a veiled world that might be a paradise, and the truth. When at last we found a way to reach beneath the veil, was the exact and total opposite of the dream. Not a paradise, but the closest thing to a furnace that a solid world can be. Venus is strange in its motions too, as if to warn us that nothing about it is what we expect. It turns on its axis so slowly that, like Mercury, a single day on Venus lasts longer than its entire year. And it turns the wrong way, backward, opposite to nearly every other world, so that on Venus, if you could ever see the sun through those clouds, it would rise in the west and set in the east. A slow, backward, hidden world, beautiful from afar and merciless up close. Venus is, by many measures, the deadliest world in the entire solar system, far more hostile than worlds much farther from the sun. It is a planet that punishes you in not one way, but several at once, each of them enough to end a life on its own, and the first of them would reach you before you even fully understood where you were. It is the pressure. Venus has an atmosphere so thick and so heavy that it barely behaves like air at all. Down at the surface, the weight of that atmosphere pressing in is about 92 times greater than the pressure you feel right now, lying comfortably under Earth's gentle sky. To find a pressure like that on Earth, you would have to dive almost 3,000 feet down into the ocean, far deeper than any swimmer could ever go, into the crushing black where the water itself becomes a kind of slow fist. That is what the mere air on Venus would do to you. In the very first instant on the surface, your spacesuit would begin to crumple inward, the way an empty plastic bottle collapses when you squeeze it. Within about a second, the suit would give way completely. And then, in the next 2 or 3 seconds, the same force would move into you. Your skin and muscle would compress. The small vessels carrying your blood would fail. Your organs would buckle under a weight they were never built to bear. It would be intensely painful, but it would be mercifully brief, perhaps 5 seconds in all. Venus would crush you the way a hand crushes paper, and it would be done almost before your mind could catch up. The brightest, prettiest light in the evening sky would simply fold you closed. But suppose, for the sake of understanding the planet, that you could somehow withstand the pressure. Venus would not be finished with you. Behind the crushing weight comes the heat, and the heat on Venus is almost beyond imagining. The surface temperature there reaches around 869 degrees Fahrenheit, hot enough to melt lead, nearly as hot as the glowing rock that pours from a volcano here on Earth. And the cruel part is that this heat is the same everywhere, dayside and nightside alike, because the thick atmosphere spreads it around and traps it. Venus does not cool down at night the way Mercury does. It is an oven that never opens. If you could feel that heat without being crushed, it would begin cooking you from the inside almost at once. Within a minute, Your core temperature would start to climb. You would feel a wave of nausea, a deep exhaustion, a sweat that could not possibly keep up. Your internal organs would begin to overheat, like an engine run too hard for too long. Your vision would darken at the edges. Within about 10 minutes, you would lose consciousness, and not long after, the heat would finish its work. To stand on Venus is to stand inside an oven the size of a planet. And even the heat is not the whole story. The air itself is poison. The atmosphere of Venus is made up of around 96.5% carbon dioxide, with most of the rest being nitrogen, and almost no oxygen at all. A single breath of it would do you no good whatsoever. It would suffocate you, and drifting through that crushing, boiling, airless sky are clouds, not of water, but of sulfuric acid. On Venus, the rain is acid. It would corrode a spacesuit and burn exposed skin, falling from a yellow sky that never clears. Crushed, boiled, suffocated and burned, all on one world, all at the same time. For a long time, we did not truly believe how bad it was, and the way we learned was through one of the bravest and saddest series of missions in the history of exploration, decades ago. A determined space program set out to land probes on the surface of Venus, again and again. The early ones simply vanished, crushed or melted long before they reached the ground, sending back nothing. So the engineers rebuilt them, tougher each time, wrapping them in thick armored shells, pressurizing them like deep-sea submarines, packing them in protective coolant. And finally, one of them made it. For the first time in history, a spacecraft transmitted a signal from the surface of another planet. It lasted only a short while before the heat and pressure silenced it, but it lasted long enough. Later probes did even better. One of them survived for around 2 hours on the surface, long enough to scoop up a little soil and send home the first photographs ever taken from the ground of another planet. Imagine the people in that control room, seeing those images appear line by line, a real picture of real rocks under a real sky, on a world that destroys everything we send to it. They knew their probe was dying as it worked. Every one of those landers was built knowing it would never come home, that the planet would crush and bake it within hours at most. We sent them anyway, because the only way to know Venus was to let her take what we offered. And so we know exactly what would happen to a person there, without a single person ever having to find out. Let us leave Venus and her acid clouds behind, and travel outward again, past the warm blue home we came from, to the next world out, this one we love, this one we dream about. This is the world we draw on the covers of books and imagine ourselves living on someday. It is reddish and rust-colored, with pale skies and great dry valleys, with ancient riverbeds where water once flowed and polar caps that grow and shrink with its seasons. Of all the other planets, it feels the most like a place we could go. This is Mars, the red planet. And Mars has a particular cruelty to it. It looks reachable. It looks almost kind. And then, given the smallest opening, it would take your life in a way that is genuinely hard to describe gently. There is a reason Mars feels so familiar, so nearly like home. Its day is almost the same length as ours, just a little over 24 hours, so that the sun rises and sets there on a rhythm a human body would recognize. It has seasons, as we do, as it leans first one way and then the other on its long journey around the sun. It has weather and clouds and white caps of frost at its poles. It even has the grandest scenery in the entire solar system. There is a volcano on Mars so vast that it rises nearly 3 times the height of the tallest mountain on Earth. A gentle slope so wide that if you stood upon it, you would not even be able to tell you were on a mountain at all. There is a canyon there so long that it would stretch across the whole of a continent. A wound in the planet deep enough to swallow our deepest valleys many times over, and 2 tiny lumpen moons circle it, far smaller than our own, hurrying around the red world like a pair of restless companions. Everything about Mars whispers that you could live there, and everything about Mars is lying, just a little. Mars sits just outside the warm zone around the sun where liquid water can easily survive. It is a smaller, colder, drier world than ours. It lost most of its atmosphere long ago, and it has no protective magnetic shield around it. What air remains is thin, far thinner than the air on the highest mountain peak you could imagine, and it is made almost entirely of carbon dioxide. There is essentially nothing there for a human lung to use, so on Mars, you would have to keep your spacesuit sealed at every single moment. Not most of the time, every moment, because the instant your suit failed, Mars would begin to take you apart. The atmospheric pressure on the surface of Mars is only about 0.6% of the pressure you feel at home. That is so close to no pressure at all that, for your body, the difference hardly matters. And here we meet one of the strangest dangers in all of space, something that sounds almost unbelievable, but is simply physics. At pressure that low, the fluids inside your body would begin to boil. Not because they are hot, but because pressure is part of what keeps a liquid a liquid. Lower the pressure far enough, and even cool fluids will turn to vapor. There is a name for what this does to a body. It is called ebulism. Picture the first few seconds after a suit breach on Mars. At first, there would be confusion more than pain, a sudden sense that something is terribly wrong. You would gasp, your breathing turning fast and shallow as your body searched for oxygen that simply was not there. And at the same time, all the careful pressure inside your suit, the pressure that had been quietly keeping you alive, would rush out into the thin Martian air. The gases dissolved in your blood and in the soft tissues of your body would begin to come out of solution and expand. Your body would start to swell and puff. It would take only minutes, perhaps 7, for it to be over. Mars gives you hope, and then, at the first opportunity, takes everything. And even if you kept your suit perfectly sealed, Mars would still try another way, and that way is the dust. Mars has dust storms unlike anything on Earth. They can rise up and spread until they cover the entire planet. A single storm swallowing a whole world, and they can last for weeks or even months on end. The strange thing is that these storms are not powerful in the way a hurricane is powerful. The thin air cannot push very hard. You could almost stand in a Martian gale and barely feel it. But the dust itself is the threat. It is extraordinarily fine, finer than talcum powder, and it carries a faint static charge. So it clings and creeps and works its way into everything. It would slip into the seams of your suit and scratch it from the inside. It would clog the filters that clean your air. It would foul the systems that keep you warm and breathing. Slowly, quietly, the dust would dismantle the very machinery keeping you alive. We learned this not by losing a person, but by losing a beloved machine. We have sent more spacecraft to Mars than to any other planet beyond our own. Landers and rovers and orbiters, a small fleet of explorers scattered across that rusty world. One of them was a little robotic rover that was meant to last only about 90 days. It lasted for nearly 15 years instead, rolling slowly across the red plains, climbing into craters, sending home tens of thousands of photographs, far outliving every expectation anyone had for it. And in the end, it was a planet-wide dust storm that finished it. The dust filled the sky and blotted out the sun for so long that the little rover's solar panels could no longer drink in any light. Its last message home, before the dark closed over it, was a simple reading that its batteries were low and the sky was growing dark. Engineers who had worked with that rover for years described it almost the way you would describe losing a faithful old companion. It had gone where we could not, lived far longer than it should have, and finally been laid to rest by the very dust we are describing now. So when we picture standing on Mars, we are picturing a place we know intimately, mapped and photographed and driven across by our patient machines, and we know exactly how it would treat us, with false hope, and then with cold efficiency. Let that knowledge stay gentle, though. You do not have to go. The little rovers went for you, and they sent the whole story home. Now we leave the small rocky worlds behind entirely. So far we have walked on solid ground, scorched or frozen or rusty, but ground all the same. From here on, that changes. We are traveling out past a wide belt of drifting rock and rubble, out into the cold and spacious outer solar system, and the worlds that wait for us there are utterly different in kind. That belt of rubble deserves a quiet word of its own, because it is not at all what its name suggests. We call it the asteroid belt, a great ring of countless rocky fragments circling the sun between the rocky worlds and the giants, the leftover crumbs from the building of the planets, the pieces that never quite gathered themselves into a world. In stories, it is often shown as a dense and dangerous field, a place where a ship must dodge and weave between tumbling boulders. The truth is far gentler and far emptier. The belt is so vast, and the pieces within it so widely scattered, that if you stood on one of them, you would very likely not be able to see another at all. The little spacecraft we sent to the outer planets sailed straight through the belt, without ever coming close to a single stone. It is mostly silence out there, mostly dark and distance. A thin scattering of ancient rock drifting through an immensity of empty space. Crossing it takes years. And for almost all of that time, there is nothing to see but the slow wheeling of the distant stars and the shrinking gold of the sun behind. It is the long, quiet middle of the journey, the patient passage between the warm worlds and the cold ones, and there is nothing to do out there but drift and wait and let the distance pass. At last the belt is behind you, and ahead, the giants begin. They are enormous, and they are not made of stone. They are made of gas and liquid and crushing depth, and they have no surface at all to stand upon. The first and greatest of them is a world so large it could swallow every other planet whole. This is Jupiter, the king of the planets. Jupiter is almost beyond the scale our minds are built to handle. It is more than twice as massive as all the other planets in the solar system combined. If you poured every other world together into a single ball, Jupiter would still outweigh it, easily. It is a vast, spinning sphere of mostly hydrogen and helium, the lightest and simplest stuff in the universe, gathered together in such enormous quantity that it presses down on itself with unimaginable force. To feel how large Jupiter truly is, try this. If Jupiter were a hollow shell, you could pour more than 1,000 Earths inside it and still have room to spare. It is so massive that it does not really orbit the Sun the way the smaller planets do. Instead, Jupiter and the Sun both circle a point that lies just outside the Sun's own surface, as though the giant were heavy enough to make even the Sun wobble. And spinning across the face of that giant is the most famous storm in the solar system. A great swirling oval of deep red cloud large enough to swallow our entire planet whole. A hurricane that has been raging without pause for at least as long as human beings have had telescopes to watch it. Century after century, never once blowing itself out. Around Jupiter wheels a whole swarm of moons, dozens upon dozens of them, some little more than captured rocks, and 4 of them great worlds in their own right. One wrapped in ice over a hidden ocean, one covered in erupting volcanoes, circling their king in the dark. To approach Jupiter is to approach not so much a planet as a small solar system of its own, ruled by a storm that never ends. And the single most important thing to understand about Jupiter, the thing that shapes how it would end you, is that there is nowhere to land. There is no ground. There is no surface. There is only sky, going down and down and down, getting thicker and hotter and more crushing the deeper you fall. So you would not so much arrive on Jupiter as fall into it. Let us go slowly here, because this is one of the strangest and most quietly dramatic journeys in the whole solar system, and it deserves to be told without hurry. Imagine descending through the top of Jupiter's atmosphere. At first, high up among the outermost clouds, it would be almost peaceful. The pressure there is only about 1/10 of what you feel at home. The air thin and quiet. The famous colored bands of Jupiter, the creams and golds and soft browns. would spread out around you in great horizontal stripes, each one a river of cloud thousands of miles wide. For a little while, it would simply be one of the most beautiful sights a human being could ever witness. Then you would keep falling, and the world would begin to change. Around 31 miles below the cloud tops, the calm would end. You would enter a region of fierce turbulence, where winds tear past at speeds of more than 220 miles an hour, faster than the strongest hurricane Earth has ever known. And here, in the churning storm clouds, Jupiter reveals one of its most spectacular weapons: lightning. Jupiter is home to lightning storms far more violent than anything on Earth. Vast electrical discharges flickering through clouds that could swallow our entire planet. The air around you would grow thick with static, a building charge you could feel in every nerve. And then, somewhere in that descent, one of those titanic bolts would find you. A single one of these strokes can release enough energy to power a great city. For anything as fragile as a human being or a small falling capsule, it would simply be the end. The systems would fail. The warmth would drain away, and you would be left tumbling through a powerless dark, deeper and deeper into a planet with no bottom. We know what that descent is like because we did it with one of the bravest little machines we have ever built. Decades ago, a spacecraft arrived at Jupiter carrying a small, tough probe designed for a single purpose. It would be released to plunge directly into Jupiter's atmosphere, to fall as deep as it possibly could and radio home what it found, knowing all the while that it was falling to its destruction. There was never any plan to save it. There could not be. It was built to die, on purpose, in the service of knowledge. Picture the moment it entered the clouds. It slammed into the top of Jupiter's atmosphere at a speed so great that the air in front of it glowed hotter than the surface of the sun, and a protective shield burned away to save the instruments inside. Then a parachute opened, and the little probe began the slow part of its fall, drifting down through layer after layer of alien cloud, measuring the temperature, the pressure, the winds, the chemistry of the air, and sending it all home across 500 million miles of empty space. Down it went, deeper than anything we had ever sent into a giant planet. Let us stay with it a moment longer, falling there in the dark, because there is a strange calm in that descent worth feeling. The little probe had no eyes to be afraid with. It simply did its work. With each layer it passed through, it listened and measured and spoke, telling us how warm the air was growing and how heavy and what it was made of, in a steady stream of faint signals climbing back up through the clouds and out into space and across that vast emptiness to the patient people waiting at home. It did not race or struggle. It could not have escaped if it tried. It simply fell and reported and fell and reported, sinking deeper into a sky that grew brighter and hotter and thicker around it, carrying out its single quiet purpose without fear, all the way to the end. The pressure climbed and climbed. The temperature rose around it. It fell for nearly an hour, descending roughly 90 miles into the crushing sky, sending back its steady stream of numbers the entire way. And then, exactly as everyone had known it would, the pressure grew too great, and the heat too fierce, and the brave little probe fell silent and was gone, melted and crushed somewhere in the endless storm. It is still down there, somewhere inside Jupiter. Its atoms long since scattered into the planet it died to understand. That is the gift the giant gives. If you let it teach you instead of harm you, we will never need to make that fall ourselves. A small machine made it for us, calmly, all the way down, talking to us until the last possible second. So when you imagine Jupiter now, you can imagine it from up here, safe and far away, as a place of impossible beauty and impossible depth, a planet you fall into rather than land upon, where the lightning is the size of worlds, and the bottom never comes. Let us rise back up out of those clouds and travel onward, because the next world is, for many people, the most beautiful object in the entire sky. It is another giant, the second largest planet of all. Another vast sphere of hydrogen and helium with no solid ground beneath its clouds. But this one wears something that no other planet wears so gloriously. It wears rings. This is Saturn, the crown jewel of the solar system, and it is breathtaking. And it is dangerous in ways that begin long before you ever reach the planet itself. Here's a small wonder to hold first. Before the danger, for all its enormous size, Saturn is astonishingly light. It is made of such airy, gathered gas that, on average, it is less dense than water, which means that if you could somehow find an ocean large enough to hold it, Saturn would float. This colossal world, second largest of them all, wide enough to line up 9 Earths across its face, is light enough to bob on water like a cork. And those famous rings, seen up close, are not one smooth band but thousands upon thousands of fine separate ringlets, like the grooves of an old record, with dark gaps swept clean between them, where small moons shepherd the ice into place. At Saturn's North Pole, there is a storm shaped, strangely and perfectly, like a 6-sided figure, a great spinning hexagon of cloud wide enough to fit several Earths inside it, holding its sharp geometric shape year after year for reasons we are still working to understand. Saturn is a world of quiet impossibilities, light enough to float, crowned in 1,000 rings, capped with a 6-sided storm. Saturn, like Jupiter, is a world you could only fall into, never stand upon. Its winds are even faster than Jupiter's near the equator, raging at well over 1,100 miles an hour, among the swiftest sustained winds anywhere in the solar system. And deep down inside Saturn, where the pressure becomes truly monstrous, something almost magical and entirely lethal happens. The hydrogen gas is squeezed so hard that it stops behaving like a gas at all and turns into a strange liquid metal, a hot, dense, electrically charged sea hidden far below the gentle clouds. To fall into Saturn would be to fall toward that impossible ocean, crushed and heated long before you ever reached it. But the most famous danger of Saturn is the very thing that makes it beautiful. The rings. From far away, they look solid and smooth, like a single sheet of pale light wrapped around the planet. They are not solid at all. They are made of countless billions of separate pieces, mostly ice, some rock, ranging in size from tiny grains of dust to tumbling chunks as large as a house. And every one of these pieces is racing around Saturn at tremendous speed, something like 43,500 miles an hour. The rings are not a peaceful halo. They are a vast, glittering, high-speed storm of ice, circling the planet in a thin, bright plane. A spacecraft, or a person, approaching Saturn without great care could simply collide with that storm of ice and stone. At those speeds, even a small piece striking you would carry the force of an explosion. The thing that makes Saturn the loveliest world in the sky, that delicate, shining crown, is also a wall of frozen shrapnel moving faster than any bullet. And here is a gentle, slightly melancholy fact to hold on to. Those rings have not always been there, and they will not always be there. By the best estimates we have, Saturn has worn its rings for only a few 100 million years, young by the standards of the solar system. And slowly, piece by piece, the ice is drifting down into the planet and being lost. In some far distant future, Saturn will be a bare giant with no rings at all. We happen to be alive during the brief cosmic moment when they exist. We are lucky simply to be here to see them. We came to know Saturn through one of the most successful and beloved missions ever flown. A single spacecraft that traveled for 7 years just to reach the planet, then spent more than a decade circling it, threading carefully between the rings, studying the storms, watching the seasons turn. It mapped the moons. It discovered worlds with oceans hidden beneath their ice. And when at last its fuel was running low, the people who had guided it for so long made a remarkable choice. Rather than risk it drifting one day into one of those possibly living moons and contaminating it, they sent their faithful spacecraft on one final journey. They steered it to dive directly into Saturn itself, plunging into the very clouds it had studied for so long, sending home fresh measurements all the way down until the friction and pressure tore it apart and it became one with the planet. The people in that control room watched the signal fade and knew they were saying goodbye. The machine had given everything, right to the end, and because of it, Saturn is no longer a mystery. It is a known and beloved world, a giant crowned in fragile, temporary ice, glowing softly in the dark, and you can picture it now in perfect safety. Onward again, farther out, into a part of the solar system so distant and so cold that only one spacecraft in all of history has ever visited it. The Sun, by now, would be little more than a very bright star, no longer something that warms you, just a point of light among the others. Out here we find the third giant, a strange and lovely world tipped over onto its side, rolling around the sun like a ball instead of spinning like a top. It glows a pale, serene blue-green. It has the coldest atmosphere of any planet in the entire solar system. This is Uranus, an ice giant, and it offers perhaps the strangest fate of any world we will visit tonight. The first strange thing about Uranus is the way it lies. Every other planet spins more or less upright as it circles the sun, like a top standing on a table. Uranus does not. At some point in its distant past, something enormous seems to have struck it and knocked it almost completely onto its side, so that now it rolls around the sun lying down, its poles pointing nearly straight at and away from the distant light. This gives Uranus seasons unlike anything we could imagine, because the planet takes about 84 Earth years to circle the sun once, and because it lies on its side, each pole spends roughly 21 years bathed in continuous daylight, followed by roughly 21 years of unbroken night. Picture a winter that lasts for 2 human decades. A single night more than 20 years long, settling over half the world, while the other half drifts through an equally endless day. A person born at the start of a Uranian night could grow well into adulthood before the sun ever rose again. It is a world that does everything slowly and sideways, and in the deepest cold of any planet there is. Uranus is bitterly, almost unimaginably cold. The temperatures high in its atmosphere can drop to around 371 degrees below 0 Fahrenheit. That is so cold that it is hard to even hold in the mind. Cold enough to freeze nearly any familiar substance solid. Cold enough that the materials of a spacesuit would grow brittle and begin to crack simply from the temperature. And Uranus, like the other giants, is no place to land. It is a deep, dense world of hydrogen and helium and water and ammonia and methane, with no firm ground anywhere within it. Let us count the ways this pale world could end a life, slowly, one at a time, because each one tells us something about what Uranus truly is. The first thing it could use against you is its own breath. Around 2% of the atmosphere of Uranus is methane, a gas that is toxic to human beings. 2% might sound small, almost harmless, but it is more than enough. Breathe that air, and within minutes, it would poison you. The very methane that gives Uranus its beautiful blue-green color, by soaking up the red light from the distant sun, is the same gas that would quietly take your life. The second thing it could use is movement. High in the atmosphere of Uranus, particles race along on fast winds, moving at speeds of several hundred miles an hour. Over time, that constant scouring stream would wear away at a spacesuit, eroding it like wind eroding stone, until at last it failed and let the cold and the poison in. The third thing it could use is the cold itself, that staggering temperature we already named, freezing the materials around you until they grew fragile as glass and shattered. On Uranus, even the smallest crack in your protection from any of these causes would be the beginning of the end. Because the moment your suit was breached, the toxic air would find you. But the fourth thing, the deepest secret of Uranus, is the strangest and most beautiful of them all. If you survived the cold and the poison, and somehow descended far down into the planet, thousands of miles below the cloud tops, you would reach a region where the pressure becomes almost unthinkable and the temperature soars. And down there, in that crushing dark, the carbon inside the methane is squeezed so hard that it crystallizes. It becomes diamond, deep inside Uranus. Scientists believe it quite literally rains diamonds, glittering stones forming high up and sinking slowly down through the dense interior like a strange and gentle storm. About 18% of your own body, by weight, is carbon. So a person who fell that deep would, given enough time and enough pressure, become part of that diamond rain. It is a grim thought and a beautiful one at the same time. Of all the ways the solar system could undo you, this is surely the most precious. You would not simply die on Uranus. You would very slowly turn to jewels. We have only ever visited Uranus once, with a single spacecraft that swept past it briefly, decades ago, on its long journey toward the edge of the solar system. In just a few hours of close observation, that one traveler gave us almost everything we know about this world. It has never been visited since. No spacecraft has ever orbited it, lingered with it, studied it season by season, the way we studied Saturn. Uranus remains, to this day, one of the great unfinished stories of exploration, a pale, tilted world glimpsed once in passing, and then left alone in the cold. We know it would freeze you, poison you, and finally turn you to diamond. And we know this from a single brief encounter long ago. A few hours of attention paid to a world that waits, patient and blue, for us to return. Let us travel on to the last true planet, the most distant of them all, a world that looks at first glance like a twin of the one we just left. It is almost the same size as Uranus. It is made of many of the same things: hydrogen and helium and water and ammonia and methane. It glows an even deeper, richer blue. But it hides one ferocious difference. And that difference makes it one of the most violent places in the entire solar system. This is Neptune, the farthest planet, the deep blue world at the edge of the Sun's family. Neptune holds a special place in the history of how we came to understand the heavens, because it is the one planet that was found not by looking, but by thinking. Long ago, astronomers noticed that the planet just inside it was not moving quite the way it should, drifting a little off its predicted path, as though something unseen were tugging at it from farther out in the dark. Two mathematicians, working separately, sat down with paper and pencil and used the gentle laws of gravity to calculate where that hidden world would have to be. They handed their answer to an observer, who pointed a telescope at the patch of sky the numbers had predicted. And there, almost exactly where the mathematics said it should be, was Neptune. A new planet found first in the mind before it was ever seen with the eye. And it is so far away, and its orbit so vast, that a single year on Neptune, one full journey around the Sun, lasts about 165 Earth years. It was only a little over a decade ago that Neptune at last completed its very first full orbit since the night human beings first discovered it. One Neptunian year is longer than most nations have existed. Out there at the cold blue edge, time is measured in lifetimes upon lifetimes. The difference is the wind. Neptune has the fastest winds anywhere in the solar system, faster than Jupiter's, faster than Saturn's, faster than any storm on any world we know. These winds reach speeds of around 1,300 miles an hour. That is faster than the speed of sound here on Earth. Let that settle for a moment. On Neptune, the wind itself moves faster than sound. Supersonic gales sweeping endlessly around a planet so far from the sun that it receives almost no warmth at all. It is one of the great mysteries of Neptune, in fact, that a world so cold and so distant, so starved of the sun's energy, should churn with the most powerful winds we have ever found. Something deep inside it drives that fury. And we do not fully understand what. These winds are not only fast, they are wild and turbulent, twisting into great swirling vortices, dark storms larger than the entire Earth that appear and vanish over the years. To fall into Neptune would be to be caught in that chaos. The supersonic winds would seize a falling spacecraft and fling it in every direction at once. The pressure and the cold and the driving methane ice would begin to tear it apart. And if it were caught in one of those spinning vortices, the storm would whirl it around with such ferocity that the spinning itself would crush the things inside. Picture being caught in that spin. As the winds whirled you faster and faster, you would feel an enormous force pressing down through your whole body. The same kind of force a pilot feels in a tight, high-speed turn, but far stronger, perhaps 10 times the ordinary pull of gravity. Under a force like that, everything inside you would suddenly feel impossibly heavy. Your organs would press down against one another. Your blood, instead of circulating freely, would be flung to the lowest part of your body and pooled there, unable to climb back up to your brain. Starved of blood, your mind would simply switch off, gently and quickly, into unconsciousness. It would take only about 5 minutes for the whirling and the pressure and the cold together to undo both the ship and the body completely, scattering them into the deep blue storm. Neptune is fast, and Neptune is final. We have only ever visited Neptune once as well, by the very same lone traveler that passed Uranus. The spacecraft that has journeyed farther from home than anything else humanity has ever built. After its brief look at Uranus, it flew on through the dark for years more and finally swept past Neptune, the last planet, before continuing out and out, beyond the edge of the solar system entirely, into the space between the stars. It is still traveling now, silent and alone, carrying its small message from a warm blue world to whatever might one day find it. That single flyby, decades ago, is the only close look we have ever had at Neptune. Everything we know of those supersonic winds and dark, vast storms, we owe to a few hours of one machine's attention, long ago. at the far edge of the known, of the... There is one more place to visit tonight, though it is not quite a planet, and reaching it means traveling even farther, out past Neptune into a vast and frozen frontier of small, icy worlds. For most of a century, this little world was counted as the 9th planet, the faithful far companion at the edge of everything, until, not long ago, astronomers gently reclassified it as something slightly different, a dwarf planet, one of the larger members of a whole population of icy bodies out there in the dark. By any name, it is beloved. People felt the change keenly, as though an old friend had been quietly renamed. This is Pluto, the small, frozen heart at the boundary of the sun's domain. Pluto is tiny, smaller even than our own moon, a little ball of rock and ice so far from the sun that the warmth which reaches it is almost nothing at all. Out there, the sun is just another bright star, and the cold is the deepest and most patient cold of anywhere we have traveled tonight. The surface temperature on Pluto drops to around 398 degrees below 0 Fahrenheit. It is among the coldest places we have ever measured. And so the way Pluto would end you is the simplest and quietest of all. It would freeze you, gently and almost completely, into the frozen landscape itself. A single small failure in the insulation of your suit, out there in that profound cold, would be enough. You would feel the frostbite beginning within about 30 seconds. A sharp creeping numbness racing inward from your skin. Within another 30 seconds, the moisture in your body would begin turning to ice, and a deep, total chill would settle into you. After about 2 minutes, your core temperature would fall below the point where consciousness can hold on, and you would slip quietly into the dark. After about 3 minutes, your body would be frozen through, and still, it would be quick and very nearly painless. The softest ending of all the worlds we have seen. You would simply become a part of Pluto's silent, frozen ground, out at the lonely edge of everything, beneath a sky where the sun is just one more distant star. For almost the whole history of spaceflight, Pluto was nothing more than a faint smudge of light, too far and too small for us to see clearly, even with our finest telescopes. It was a world we had named and numbered and loved without ever truly seeing it. And then, only about a decade ago, after a journey of 9.5 years across roughly 3 billion miles, a small, fast spacecraft finally swept past Pluto and, for the first time in history, showed us its face. And it was nothing like the dead gray rock many had expected. There were soaring mountains made of water ice, hard as stone in that terrible cold. There were broad, smooth plains of frozen nitrogen, and, most touching of all, a vast pale region shaped almost exactly like a heart, spread across the surface of that distant little world. After all those years and all those miles, Pluto greeted us with a heart. The people who had spent decades of their lives sending that one spacecraft on its way wept when the pictures came home. There is a gentle detail to that mission that is almost too tender to believe. Pluto was first discovered as a faint moving speck on photographic plates by a young man working at an observatory nearly a century ago. He spent painstaking nights comparing images of the sky, searching for the one tiny dot that shifted against the fixed stars. Until at last he found it. He gave his life to the study of the heavens, and when, long after his death, we finally built a spacecraft to fly out and see the world he had discovered, his family placed a small portion of his ashes aboard it. So when that spacecraft swept past Pluto and showed us its frozen heart, a piece of the very man who first found it was there too, carried 3 billion miles across the dark to meet the world he had glimpsed only as a speck of light. He is still out there now, traveling on past Pluto with the spacecraft, farther from home than any human being has ever gone. Pluto, for all its cold and distance, also carries one of the warmest stories in all of exploration. And it does not travel entirely alone. It has a companion moon so large, compared to Pluto itself, that the two of them swing around a shared point in space between them, like two dancers holding hands and turning slowly together at the edge of everything. So even the coldest, most distant, most overlooked little world out there turned out to hold its own quiet beauty. We sent one small explorer across an almost unthinkable gulf of space and time, and it answered every question we had carried for generations, and gave us a frozen heart in return. That spacecraft, too, is still traveling, even now, deeper into the dark beyond Pluto, visiting other small frozen worlds and carrying our curiosity ever farther from home. And there our journey through the worlds comes to its end. We have gone all the way out, from the burning rock nearest the sun to the frozen heart at the very edge. And we have looked, calmly and without flinching, at what each of these places would do to a fragile, breathing human body. Let us pause now, gently, and ask what all of it actually means. Because underneath the long catalog of dangers, there is something quietly tender waiting to be noticed. Every single world we visited tonight would kill you, and each one would do it differently. Mercury would freeze you in the dark or burn and irradiate you in the light. Venus would crush you, then boil you, then suffocate you, then dissolve you in acid, all at once. Mars would lull you with false hope, and then boil your blood or smother you in dust. Jupiter would drop you into a bottomless storm and strike you with planet-sized lightning. Saturn would dash you against a wall of racing ice or pull you down toward a sea of liquid metal. Uranus would freeze you and poison you and slowly press you into diamond. Neptune would seize you in supersonic winds and spin you into nothing. And Pluto would simply, quietly, freeze you into its silent ground. 8 worlds, 8 different deaths. And then there is the 9th place, the one we started from, the one you are lying on right now, the one world in all of this, the only world we have ever found anywhere, where you can step outside with no suit, no shield, no machine keeping you alive, and simply breathe. Where the temperature is gentle, where the pressure is exactly right, where the air is not poison, but the very thing that keeps you alive, where water falls from the sky as soft rain instead of acid, and the wind, even at its wildest, is something a person can stand against and survive. We almost never see it, because we are inside it. It is like asking a fish to notice the water. But tonight, having traveled out across all those hostile and magnificent worlds, perhaps it is a little easier to feel. The thing that keeps you alive is not effort, or struggle, or cleverness. It is simply that you happen to be in the one place that was made for you. Or rather, the one place that made you, long ago. A famous scientist looked at a photograph of the Earth taken from far out in the solar system, so far that our entire world was nothing but a single, tiny point of pale blue light, smaller than a speck of dust in the vastness. And he reflected that everything that has ever happened to every human being who has ever lived, every joy and every sorrow, every kingdom and every quiet morning, took place on that one small mote of dust hanging in a sunbeam. Everyone you love, everyone you have ever known, all of it on the pale blue dot. And the rest of the solar system, all those enormous and beautiful and deadly worlds, is the proof of how rare that dot really is. We did not learn how precious the Earth is by staring at the Earth. We learned it by going out, by sending our small, brave machines to all the places that would destroy us, and discovering, world after world, that none of them would have us. The cosmos is full of wonders. It is almost entirely empty of welcome. There is, as far as we have ever found, exactly one doorstep in all the dark where life can simply sit and rest. You are on it. Stay with that for a moment. Here in the warm, on the world beneath you, you can lie down on the bare ground under an open sky and come to no harm at all. You can stand in the rain and feel it cool and clean on your skin. You can walk out into a winter morning or a summer evening and breathe air that asks nothing of you but to be breathed. You can drink the water. You can feel the wind on your face and call it pleasant. Every one of those small, ordinary pleasures, the rain, the air, the wind, the warmth, would be a swift and certain death on any of the worlds we visited tonight. The acid that falls on Venus, the dust that smothers Mars, the cold that freezes Pluto. Here, the very same forces are gentle. Here, the rain feeds the gardens, and the wind carries the scent of the evening, and the cold of winter gives way, always, to spring. We do not live in spite of our world. We live because of it. Held and fed and warmed by it in 10,000 quiet ways we never have to think about. None of these little spacecraft built themselves. Each one was the work of hundreds, sometimes thousands, of ordinary human beings, working quietly for years in plain rooms, far from the worlds they were reaching toward. Someone shaped each delicate instrument by hand. Someone wrote the long, careful lists of commands. Someone tested each piece again and again to be sure it would survive the cold, the heat, the radiation, the years of travel, and then they let it go, sent it off across the dark, and waited. That waiting is its own kind of patience, and there is something deeply human and deeply soothing in it. When a spacecraft drifts far enough away, even its radio signals, traveling at the speed of light, take hours to reach us. So the people in the control rooms learned to wait. They would send a command and know that the answer could not possibly return for hours. They would gather quietly when a probe was due to fly past some distant world, knowing that whatever was happening out there had, in truth, already happened hours before, and that the news of it was only now arriving, like starlight, across the emptiness. They would sit, and they would wait, and when at last the faint signal came in, carrying its pictures and its measurements from a place no human will ever stand, they would weep and laugh and hold one another. All of that quiet, patient love is folded into the facts we have shared tonight. Every number came home because someone, somewhere, waited up through the night for it. So let this be the gentle gift the planets give you tonight. Not fear, but gratitude. You spend your days, as we all do, inside a world so safe that you forget it is keeping you alive with every breath. Tonight, you went out and saw what the alternative looks like. You saw the crushing and the burning and the freezing and the poison. And through it all, your body stayed exactly where it is, soft and warm and breathing. In the one place that holds you, there is nothing you needed to do to earn that. You only had to be here. And here you are. Let us gather the whole long journey together now, one last time, and then let it go. It begins. As so many things do, with a question asked in the warm and the safe. What would the other worlds really do to us if we ever went and to answer it? We did not send ourselves. We built small, patient, beautiful machines, and we sent them out in our place, across distances too large to feel, into places we could never survive. It begins with the little world racing closest to the sun, frozen in the long night, scorched and irradiated in the day, where a probe still rests in the dust after years of faithful circling. It moves outward to the bright and lovely planet that fooled us for centuries, the one that crushes and bakes and suffocates and burns all at once, where brave armored landers gave us our first picture from the surface of another world before the heat silenced them. It travels past our own blue home to the red planet that offers hope and takes it back, where a small rover wandered for 15 patient years until the dust storm dimmed its sky for the last time. It moves out past the belt of rubble to the great king of the planets, the giant with no bottom, where the lightning is the size of worlds, and a tiny probe fell for nearly an hour, talking to us all the way down, before the depths swallowed it. It rises to the ringed jewel, the crowned giant wearing its fragile, temporary halo of racing ice, where a beloved spacecraft circled for years, and finally dove into the clouds it loved. It reaches the pale, tilted world that freezes and poisons, and, in its crushing depths, rains diamonds, seen only once in passing long ago. It arrives at the deep blue planet at the far edge, where the wind blows faster than sound and the storms are larger than the earth. Also glimpsed only once by the lone traveler now leaving the solar system forever. And it ends at the small frozen heart beyond the last planet, the tiny world that greeted us with mountains of ice and a pale shape like a heart. After a spacecraft crossed 3 billion miles of dark to finally see its face. 8 worlds, each one a different ending. Each one studied for us by a small machine that went where we could not and told us everything it learned before it fell silent. And around all of them, the one quiet truth at the center of it all. The only world that does not want to end you is the one you are resting on tonight. There is nothing to remember now. You do not need to hold on to a single fact of it. Let the numbers drift away, the temperatures and the speeds and the pressures, all of it loosening and floating off into the dark like the spacecraft drifting out past the last planet. You have come a long way tonight, all the way to the edge of the solar system and back, and there is nothing left to do but rest. Let it all go. Feel how heavy and easy your body has become. There is no crushing pressure here, only the soft, perfect weight of the air you were made to breathe, holding you exactly as it should. Let your limbs grow heavy and warm. Let your hands rest wherever they are, soft and still. Let the small muscles around your eyes loosen, and your jaw soften, and your forehead smooth itself out. Let your breathing slow on its own, in and out, in and out, like a quiet tide on a calm and distant shore. You are not on any of those far worlds tonight. You never have to be. You are home, in the one safe place, wrapped in the gentle air of the only world that holds you. The day behind you is finished now, and there is nothing left in it for you to carry, nothing to fix, nothing to solve, nothing to fear. You are warm. And you are safe, and you are exactly where you belong. Let each breath grow a little slower than the one before. Let each thought grow a little softer, a little farther away. The planets are still turning out there in the dark, vast and beautiful and far, far from here. And they ask nothing of you at all. You can simply let them turn. You can simply rest. There is the small, fast world nearest the sun, turning slowly through its long day and its long night, and it asks nothing of you. There is the bright, veiled world with its acid clouds, turning quietly backward beneath the stars, and it asks nothing of you. There is the red planet with its great, still volcano and its endless dust, turning in the pale light, and it asks nothing of you. The giants are turning too, the king with its endless storm, the crowned world with its 1,000 rings, the pale sideways world raining its slow diamonds, the deep blue world with its winds that never tire, all of them turning, far away, in the dark and the cold, asking nothing of you at all. You do not have to go to any of them. You never did. You can let every one of them turn without you and simply stay here, warm and breathing, on the one world that wants you. Feel your breathing grow slower still. There is nothing left to picture, nothing left to follow. The numbers are gone. The distances are gone. The cold and the heat and the wind are all far behind you now, and they were never really yours to carry. You are here. You are warm. You are held. The air moves in, and the air moves out. Gently, all on its own, the way it has your whole life long, the way it will go on doing while you sleep, with no effort and no worry from you at all. Let your body grow heavier and softer with every breath. Let the bed beneath you hold all of your weight so that there is nothing left for you to hold up. Let your hands rest. Let your shoulders rest. Let the small muscles of your face go loose and easy. There is nowhere to be. There is nothing to finish. There is only this: the quiet, the warmth, the slow and steady tide of your own breathing, carrying you down, gently, into rest. Out at the edge of everything, a small frozen world wears a pale shape like a heart, drifting in the quiet beyond the last planet, watched over by the gentle dark. And here, on the one warm world that loves you, you are held just as softly. Rest now, sleep deeply, and let the gentle dark hold you until morning.